Yeah, so good morning. So let us start chemistry. First one, Schottky defect in crystals is observed when? So it is given by ionic compounds. So suppose take a crystal lattice containing a regular arrangement of cations and anions. I will take this is plus, minus, plus, minus, plus, minus, plus, minus, like this, alternate ions. Now there is no disorder here, but one cation, one anion pair is missing. A pair of ions missing. Pair of ions missing. From lattice sites to maintain electrical neutrality. That is purpose of pair of ions loss. So pair of ions means opposite charges. Suppose here cation loss. So cation loss. Then anywhere in the crystal lattice there is anion loss. That is called pair of ions loss from their lattice points. Therefore, crystal is called neutral in nature. That is why ion leaves from normal site. Not correct. Unequal number of cations, anions. Not correct. Pair of ions means one cation, one anion to maintain charge neutrality. Density of crystal increases. No, density decreases because loss in mass. That's density decreases. Equal number of cations and anions are missing from the lattice. So this is only one correct option because of same number of cations and anions are missing from the lattice sites. Therefore, to maintain neutrality and thereby because of missing of this cation and anion, the mass decreases, density also decreases. So density of crystal increase wrong, density of crystal is decreased. So answer only fourth one. Appearance of color in the solid alkali metals, halides is due to. That is, I will take example of sodium chloride. So this is called example of sodium chloride. Sodium plus and chloride minus. Now, it is on heating with sodium vapor. Sodium vapor on heating. Sodium vapor and sodium chloride on heating, it undergoes ionization to form Na plus electron. Now, this Na plus comes to surface. That is, it is original lattice. Original lattice. Now this extra sodium occupies on surface of this NaCl, that is Na plus. Now to balance the charge, one chloride ion will come to surface. One chloride ion come to surface to balance the charge. So this plus is balanced by this chloride ion from here. That means now it is vacant. Now it is a vacant. Chloride ion come to surface. That is NaCl new lattice. But this place is occupied by the electron liberated by the sodium metal. That electron enters into this space. That space is called F center. That F center responds for color formation. Color formation. That is, these electrons will give golden yellow color. Sodium chloride in sodium vapor and heating gives gold yellow color. So first sodium chloride is having regularity of Na plus Cl minus. On heating sodium vapor, sodium undergoes ionization to form Na plus plus electron. This sodium ion occupies the surface of that NaCl crystal lattice that is found new lattice points. From the inner part, one chloride come to surface. That is one Cl come to surface, leaving one vacancy in the lattice point. Our vacancy is occupied by electron liberated by the sodium ion to form this electron. That place is called F center because F center means 4-benzene means color formation in the Latin naming. That is why F center occupied by the electrons. That is responsible for color formation for these all alkali metal halides. Similarly, KCl gives violet color. Lithium salt gives lilac, that is crimson red color. Lithium gives crimson red color. Potassium gives violet color. Sodium gives yellow or golden yellow color because of same reason F centers for the color formation. Which of the following metal oxide is antiferromagnetic? Antiferromagnetic means number of upward domains is equal number of downward domains. Upward domains is equal to downward domains. That means a group of unpaired electrons, upward 1, 2, 3, that is called upward domains. A group of downward 1, 2, 3, that is called net moment is cancelled. That's why net moment is cancelled. Therefore, it's called antiferromagnetic. But how to find out means manganese compounds are called antiferromagnetic. MnO2 as well as one more example, MnO also antiferromagnetic. This is TiO2, titanium dioxide. Titanium plus 4, no unpaired electron, that is 3d0. 3d0 is called diamagnetic. NO2 paramagnetic due to unpaired electron. Due to odd electrons or unpaired electrons. Odd electron means N valency 5, O valency 6. 6 plus 6, 12 plus 5, 17 is an odd number. Odd number containing all valence electrons is called paramagnetic in nature. So NO2 is called paramagnetic in nature. This is CrO2 example of a ferromagnetic. Ferromagnetic means same alignment of domains. That is highly paramagnetic CrO2. So MnO2, MnO is called antiferromagnetic. Least symmetry. Least symmetry means A is not equal to B, not equal to C. Alpha not equal to beta, not equal to gamma, not equal to 90 is called triclinic. That's why least symmetric is called triclinic. Percentage of available space in the BCC element. BCC meaning is nothing but 8 corners and one body center. One body center. 8 corners, 8 into 1 by 8. One body center, 1 into 1. Total value 2 is called effective number or Z effect number. Okay. Packing fraction equal to volume of Z effective atoms by volume of unit cell. Two atoms. 2 into 4 by 3 pi r cube volume of unit cell. All sides are equal. That is called A cube. On solving this value, we will get 68%. 68% is occupied. Occupied. Remaining is empty space. But question is occupied. 68% is occupied. Then memorize this value because BC is 68%. FCC and HCP contains 74%. FCC and also HCP 74% occupation and BCC contains 68% occupation. Solid CO2 example of carbon dioxide contains C double bond O and double bond O. Another one is for C double bond O, double bond O. These two molecules are held by van der Waals forces. Van der Waals forces. Therefore, it's called molecular solid. Molecules held by van der Waals forces. Molecular solid or molecular crystal. Position of chlorides in the NaCl. Chlorides is called FCC arrangement. FCC means all corners and all face centers. That is 8 corners and 6 face centers. Corners of the cube, centers of the face of the cube, corners as well as center of the faces. That is answer 3. Mole fraction of 20% aqueous solution of H2O2. 20% means 20 grams H2O2 present in 100 gram solution. Therefore, mass of solvent equal to 80 grams. Solvent is water because aqueous given. So, moles of H2O2 20 by 34. Moles of water 80 by 18. Now question, mole fraction of water. Mole fraction of water equal to mole fraction of water. Moles of water by total moles. Moles of water is 80 by 18 by 80 by 18 plus moles of H2O2 20 by 34. That gives around 68 by 77. Elevation of boiling point of a solution 10 grams of solute in 100 grams of water is delta TB. The bilioscopic constant of water is. First, elevation of boiling point formula. Delta TB is equal to Kb into molality into I. But I is not given, taken as 1 for ideal or non-electrolyte, means does not dissociate, like urea, because not given here, you can take urea like type of molecule. So delta TB given, elevation of boiling point of solution is given, delta TB, same symbol. Kb find out, Kb name is called ebullioscopic constant. Molality. Therefore, delta TB is equal to Kb into molality mass by molar mass 1000 by mass of solvent in grams. So delta TB is equal to Kb into mass is 100 grams, molar mass, so 10 grams, 100 grams molar mass into 1000 by solvent is 100. So cancel. Therefore delta TB equal to Kb. This is elevation of boiling point. I is taken as 1 for ideal or non-outright. Osmotic pressure at 0 degrees centigrade is 2 atm. What is osmotic pressure at 273? That is temperature and pressure comparison. Pi is equal to CRT. Now C and R taken as constants. Pi 1 by pi 2 is equal to T1 by T2. Pi 1 first pressure 2 atm. Pi 2 find out first temperature 273 by 546. Therefore T2 is equal to 4 atm. Pi 1 by pi 2 equal to T1 by T2. The formula of comparison of osmotic pressure. Which salt have Vanta factor is equal to potassium ferrocyanide. I value for K4 FeCN 6 equal to 4 potassiums, 1 complex, 4 K plus ions plus 1 complex ion. Total number 5 ions. So we want 5 value, that is aluminium sulfate Al2 SO4 thrice is equal to 2 aluminum cations and 3 sulfate anions, total number 5 ions. That means I value same for potassium ferrocyanide and also aluminium sulfate. Normality of 1 molar phosphoric acid is H3PO4 structure equal to so tribasic n factor 3. Now normality is equal to molality n factor. Molarity 1 n factor 3 is equal to 3 normality. As a result of osmosis, volume of less concentrated solution, flow of solvent from low concentration to high concentration is called osmosis. So flow of solvent from low concentration to high concentration. That means loss of water takes place from less concentration. That is called loss of solvent takes place means volume decreases. Loss of solvent. A transfer of solvent, flow of solvent from less concentration to high concentration is nothing but osmosis. Presence of sunlight. Decomposition on metal surface as catalyst and enzymatic catalysis. These three are examples of zero order reactions. presence of sunlight, decomposition of metal surface as catalyst, enzymatic catalysis, examples of zero order. So this is called present sunlight, order equal to 0. But molecularity is number of molecules present in the elementary step. The given step is taken as a elementary step because mechanism is not given here. That is why the given step is taken as elementary step. Elementary step contains 1 plus 1, 2 molecules. 2 molecules. Therefore, molecularity equal to 2. Order 0. Order 0, molecularity 2. Answer 0, 2. Reversible reaction. Two NO2 gives rise to K1, K2, N2O4. First you separate these steps. First forward. Because first forward only. Because forward reaction means NO2 combined to form N2O4 first. That is minus 1 by 2 d of NO2 by dt. d of NO2 by dt is equal to K1 into concentration of reactant NO2 raised to 2 moles. Backward direction. The backward direction, this is reactant to this product. Minus d of N2O4 by dt equal to K2 into N2O4 concentration. This direction. N2O4 to NO2. Net amount of N2O4 present is equal to forward rate minus backward rate. Forward is K1 into NO2 whole square. Backward is K2 into N2O4. Net amount, because first time 2 NO2 converted to N2O4. Later on some amount of N2O4 converting into 2 NO2. Some amount of N2O4 converting into NO2, but not total amount of N2O4. That is why it forms a later equilibrium condition. So after equilibrium condition, what is the amount of N2O4 left? Net amount of N2O4 present at the system is equal to RF minus RB, rate of forward minus rate of backward reaction. That is equal to this one, K1 NO2 square minus K2 N2O4. Now, total rate is equal to, therefore total rate of reaction for 2 NO2 gives rise to N2O4 is minus 1 by 2 dNO2 by dt is equal to dN2O4 by dt, means formation of N2O4. We are taking only for this reaction, total reaction is equal to K1 into NO2 whole square minus K2 into N2O4. Now we want rate with respect to only NO2. Therefore, NO2 rate is equal to minus d of NO2 by E2 taken that side, 2 times of K1 NO2 whole square minus K2 N2O4. So first to forward, backwards, find separately rate for forward, rate for backward reaction. At equilibrium, net amount of N2O4 present in the system is equal to Rf minus Rb. Therefore, total rate of reaction for the reaction minus 1 by 2, reactant side minus 1 by 2, d of NO2 by dt, product side plus formation of dN2O4 by dt is equal to net amount of Rf minus Rb value. That is minus d of NO2 by dt with respect to disappearance of NO2, E2 taken that side 2 times of that value. 2 times means answer 2. 3a due 2b, rate expressed for dB. First, rate of reaction is equal to minus 1 by 3 dA by dt, minus indicate disappearance of reactants, decrease in concentration of reactants, is equal to plus 1 by 2 dB by dt, rate of formation of products. So, the total value is called rate of reaction, but only this value is called rate of formation with respect to B. Now the question given now rate of formation of B. So bring it to this side. That is minus 2 by 3 dA by dt is equal to dB by dt is called rate with respect to B or rate of formation of B, minus 2 by 3 dA by dt. Answer 2. Exothermic reaction A gives us B activation energy 170. Heat of reaction 130. Activation is backward reaction. For any reaction, this is same formula, delta H of reaction is equal to, means enthalpy change of the reaction equal to EAF minus EAB, means activation energy of forward minus activation energy of backward. This formula is constant for any type of reaction, maybe exothermic reaction or endothermic reaction. Don't change this formula because sign automatically changes according to type of reaction, exo and endo. That is why formula is constant for the both exothermic reaction as well as endothermic reactions. Now substitute the value given. It is given as exothermic. Exothermic means the delta H value equal to minus 130. It should be minus. So we have to put minus 130. Maybe given as plus 130, it is taken as minus 130 since given as exothermic reaction. XO is minus 130. EAF means forward activation. Forward is given as 170. Same unit, kilojoules only, 170 minus EAB find out. Therefore, EAB is equal to 170 plus 130. 300 kilojoules. So delta H of reaction equal to EAF minus EAB, but one condition, precaution, that is 130 given, it is taken as minus 130 in the problem solving because delta H is negative for the exothermic reaction. A plus B is slow, X used to AB fast. Slow means high activation energy. Slow meaning is called high activation energy. Fast meaning low activation energy. That means there are two peak points. First peak point is very high activation, second is low activation to form intermediate compound. So here two peak points present. Here two peak points. But first should be high, second should be low. This nearly equal. This is correct one because first one is high, second is low. Therefore, this is called more activation energy is called slow step. This is called fast step. So answer 2. Half-life period for gaseous reaction with initial pressure is 80 kilopascal 350 seconds, and for 40 kilopascal half-life period 175. So what is comparison of half-life with pressure or concentration means T half proportional to 1 by A raised to n minus 1. This is common formula for all types. Now comparison wise, half-life of first one by half-life of second one is equal to A2 by A1 raised to n minus 1, or P2 by P1 raised to n minus 1. For concentration, A2 by A1. For pressures, use P2 by P1. Now first half-life is 350. 350 divided by second one 175 is equal to second concentration 40 kilopascal. First one 80 kilopascal raised to n minus 1. So 2 times cancel, this by 2 times. So 2 is equal to 1 by raised to n minus 1. Take reciprocal. Therefore 1 is equal to 1 minus n is equal to 0. So it is called zero order reaction. Free energy change and equilibrium constant, the direct formula only, minus G is equal to 2.303 RT log K, because log given, this is 2.3. If log not given, then ln, but minus requirement. Charge required for reduction of 1 mole of dichromate to chromium. Take the change in oxidation number. Dichromate formula Cr2O7 2 minus, take 2 chromiums because here Cr2 present. So that means element first balance. If it is 1 present, then take 1. But 2 present, take 2 atoms. 2x minus 14 is equal to minus 2. 2x equal to 12. That's all. 2x value requirement. Because 1 mole of the compound has 2 atoms of chromium, they are involved in the chemical reaction. Therefore, take 2x value for the 1 mole of the compound. Same 2x value on the product side also. X equal to 3, 2x equal to 6. Now difference equal to n factor. That means for 1 mole of compound, this is 12 to 6 reduction. Reduction is equal to Faraday into N. Charge required equal to Faraday into N. Charge required equal to Faraday into N. Faraday is 96,500 coulombs. N factor equal to 6. Okay, that means for 1 mole of the compound, take the same number of atoms in the formula to find out the N factor. 1 mole has 2 chromium, 2x value 12. Same 2x value also on the product side. N factor equal to 6. So 1 mole of the compound to undergo deposition or maybe redox reaction, the charge required equal to Faraday into N factor. Equivalent conductance of sodium chloride NaCl and C2H sodium propionate given are different dilution. the equivalent conductance of CH2H5COOH. So equivalent conductance of C2H5COH is a weak acid. Weak acid does not dissociate completely. That's why it is calculating through indirectly from strong electrolytes. First C2H5CO requirement. Where is salt? Lambda equivalent of C2H5CONA plus H requirement HCl. Lambda of HCl. But we don't want to chlorine and sodium. That means subtract lambda equivalent of sodium and chlorine. C2H5CONA means third value 91 plus HCl middle value 426. Next NaCl first value 126.45 gives around 390. 2.5 Faraday passing through copper sulfate. The number of gram equivalents of copper deposited is 1 gram equivalent of any substance requires 1 Faraday. It is a constant. 1 gram equivalent of any substance requires 1 Faraday. But 1 mole of the compound requires 1 Faraday into N, where N is equal to valency or N factor, change in number of electrons. So it is 1 equivalent. 2.5 Faraday, 2.5 equivalents. 2.5 equivalents. Cell constant. Cell constant is L by A, centimeters by centimeter square, inverse centimeter. Molar conductance of KCl increase slowly on dilution. That is, for dilution, molar as well as the equivalent conductance increases because K plus and Cl minus are attracted by lattice energy or ionic forces. That is called ionic forces. Now to break this ionic force, add more water. Then K plus surrounded by water molecules. Cl minus separated by say water molecules. Now ions get separated. Then for mobility of ions increases. Weakening of inter-attract forces increase ionic mobilities. That is why conductivity increases. So force of attraction we have to break down. To break that force of attraction, add more amount of water, the ions get separated and ions becomes hydrated. Mobility increases because they present as now independent ions without any force of attraction between K plus and Cl minus. That's why inter-ionic attractions are reducing and increase the ionic mobilities. Oxidation number of chromium is normal only, plus 2, 2x or 2 chromium, minus 14 equal to 0, x equal to plus 6. We can question your one chromium atom in this formula only. That means 1 chromium atom formula plus 6. Transition metals do not form amalgam. So mercury reacts with all metals to form amalgam. So except iron and platinum. Thermodynamically more stable metal is iron. Platinum is thermodynamically more inert metal, does not react. So iron and platinum do not form amalgams, both 2 and 3. Actinoids are plus 7 state. That is, we have to remember in the textbook NCERT table given oxidation numbers. So follow all NCERT table values, oxidation numbers. So neptunium and plutonium gives very high value of plus 7 state. Only 2 elements. Neptunium and plutonium. Next, increasing order of basic nature of hydroxides from plus 3 state. Due to lanthanide contraction, ionic radius decreases. Ionic nature decreases. Basic nature of hydroxides also decreases because of decrease in ionic nature. Highly ionic compounds are strong bases, but down the group covalent character increases. Covalent character is a weak basis. That's why lanthanum is a strong base. Next element is called cerium. Next praseodymium. Last lutetium. So lanthanum strong base, lutetium weak base. LaOH thrice is a strong base. Lutetium, last one. Lutetium hydroxide is a weak base. So answer 2. Colored and paramagnetic means the presence of unpaired electrons. Presence of unpaired electrons. Cu plus 1 no unpaired, Ag plus no unpaired, but cobalt 2 plus contains unpaired electrons. Two unpaired electrons for cobalt 2 plus. In aqueous solution, dash is a good oxidizing agent. This is simple one. First, plus 3 is called common oxidation state for all F block elements, plus 3 state. But some elements have plus 2 also present. Some have plus 4 also present. 4 into 6 is called, 4 into 3 is called reduction. Process reduction. But compound is called oxidizing agent. Same. 2 to 3 is called increase, is called oxidation. Process oxidation, compound is called reducing agent. So plus 2 is called reducing agent, plus 4 is called oxidizing agent, plus 3 is called common and stable oxidation number for all F block elements. That's why with respect to common value, we have to compare the nature of reaction. 4 into 3 is called reduction, compound is oxidizing agent. 2 into 3 is called oxidation, compound is called reducing agent. So now the question given oxidizing agent means we want plus 4 state. Not a ore of iron. Limonite correct? Iron ore. This correct? Magnetite. TITE. Siderite. Cassiterite is nothing but SN. Not a ore of iron. During electrolytic reduction of aluminium, carbon anodes replaced from time to time because the carbon anode gets decayed. Carbon prevents atmospheric oxygen from coming to contact with aluminium. Oxygen liberated at the carbon anode reacts with the CO and CO2. Right. O2 liberation at the anode. The anode made up of carbon easily combined to form CO and CO2. That's why time to time we have to replace with the carbon rods, new rods, graphite rods or carbon rods. Next, electromagnetic separation is used in the concentration of. That is the separation of magnetic material from non-magnetic impurities, or separation of non-magnetic material from magnetic impurities. A tin stone contains small amount of magnetic impurities. Like FeWO4. FeWO4. That's why this is using. Calcitrate not a magnetic. Among the following metals can be registered by smelting. Means using some reducing agent. Aluminium, magnesium, sodium or electropositive metals. Electropositive metals extracted from their fused salts. This is using by smelting, because less electropositive metal using coke as a reducing agent in the smelting process, we can prepare the iron extraction. In metallurgy of iron, when CaCO3 is added blast furnace, calcium appears as a slag. Flux plus gang is equal to slag. CaO plus SiO2 come into form. CaSiO3 is called slag. This is called flux. In roasting, the ores are generally converting into the air. Roasting means in the presence of air, decompose into oxides. Most effective for coagulation of gold soul. Gold soul is negative soul. So gold is negative soul. Coagulation by positive ions with a high charge value plus 3 commonly. I think this is correction. This may be aluminum sulfate. But not. If it is not there, then go to magnesium, because magnesium charge value Mg2 plus, sodium plus 1, K plus 1, Na plus 1, but Mg only plus 2 charge. That's why if it is aluminum sulfate not given, then go to magnesium chloride, because gold is a negative soul. Wrong statement about micelles. Micelles are formed by surfactant molecules above particle concentration called CMC. Correct one? That is nothing but definition of CMC. Next, micelles are formed by surfactant molecules above a particular temperature called Kraft temperature. This was correct one. For soaps, CMC value 10-4 to 10-3 moles per liter. Also correct one. The conductivity of solution having surfactant molecules increases. Wrong, because decreases due to grouping of molecules. So number of ions decreases because it becomes one micelle unit. Micelle unit. So nearly 60 to 100 ions combine to form one micelle unit. That's why individual ions decreases. Therefore, conductivity of solution decreases due to grouping of ions into micelle formation. That is why conductivity decreases. That is the wrong statement. Adsorption is a spontaneous process. Delta G negative. Delta S negative because settled on the surface of the substance. That's why entropy decreases and formation of the bond between surface and that adsorbate and adsorbent is bond formation is exothermic nature. That's why all of them negative values. Delta G less than 0, S less than 0 and H less than 0. Enthalpy is negative, but physical adsorption is less enthalpy of negative value and chemical is more because more strong bond formation. So all of the negative values. Entropy negative because the individual molecules are settled on the surface. That means randomness decreases due to the adsorption on the surface. So all negative values. Homogeneous catalysis. What is meaning first? Reactants and catalyst. Reactants and catalyst are in same phase or same physical state. Hydrogenation of oils not correct na? Because nickel is a solid. These are gases. Ammonia by Haber process not correct. Fe is a solid, but N2H2 are gases. Sulfuric acid by lead chamber process. This is correct one. 2SO2 gas plus O2 gas use rise to 2SO3. NO, nitric oxide is a gas. That method name is called lead chamber. If vanadium pentoxide using contact process, that is contact process called V2O5. Is a solid, heterogeneous catalysis. But homogeneous means lead chamber process. NO gas is called catalyst. Effective treatment of eye disease. That is memory based. Remember the applications of that surface chemistry given. Colloidal silver. Wrong about physical adsorption. Involves van der Waals forces correct. Low enthalpy of adsorption correct. Independent of critical temperature reversible. Critical temperature means a temperature above which is impossible to liquefy the gas and applying whatever the pressure, but it depends on the critical temperature because gas is adsorbed on the surface. That means liquefaction increases na? Gaseous state molecules. Gas molecules come closer and condense on the surface. That is called condense on the surface. Depends on the TC, critical temperature. So this is wrong. Depends on the critical temperature. Both of them. That is physical and chemical. This also uses of colloidal salts. That is 1. T, that is Kala-Azar. 2. Q, that is Argyrol or silver sol. 3 are Aquadog, colloidal solution of graphite. 4S, purple of caseous, colloidal solution of gold in water. 5P, collodion is cellulose nitrate shaken with ethanol, which is not oxidized by ozone. KMnO4 because already highest value present. Plus 8 not possible. Plus 8 not possible. That's why KMnO4 is not oxidized by ozone. This is also property of phosphorus as per the textbook only. white phosphorus or yellow phosphorus, 75% p character, because phosphorus structure equal to sp3 hybridization, 25% s character and 75% p character, and poisonous, reactor alkali and toxic, poisonous. Angle is 60, very less angle. This is more angle, strain. Remaining are same properties of the phosphorus allotropes. That is, one is coincident, all of them. That is 1D, 2E. Red phosphorus is a polymer. All phosphorus join together to form polymeric state. That means this bond will break up and join with side chain. That is called linear chain formation. Less volatile because polymer in nature. Insoluble in water and also CS2. Correct one. 3C. Black phosphorus, thermodynamically more stable one. Correct one. 4B. Alpha black. Sublimatory, opaque, monoclinic, rhombohedral, does not oxidize in the air. Correct one. And 5A, alpha black, does not burn in air up to 673 Kelvin. Means stable up to 673 Kelvins. PBr6 minus F. F is unknown because PBr5 solid state present as PBr4 plus and Br minus. But PCl5 solid state present as PCl4 plus and PCl6 minus. 6 bromines cannot be accommodated due to large repulsions around phosphorus atom. That's why PBr6 not possible. Large size of bromines cannot be accommodated. That reason also called due to steric hindrance, unknown compound. Right. Oxygen acids, these are preparations. That is, we have to memorize these values. There is no other methods. That is H3PO2. A4, white phosphorus alkali gives HPO2. B3, P2O3 plus water. This is P2O3 or also sometimes P4O6 because dimeric form. This also P4O10, right? Correct. C2, that is H3PO4 from P4O10, and D1, that is from red phosphorus and alkali. That is in the textbook given. Follow same preparation methods. The mixture of HCl, HNO3 3:1 ratio contains 3 HCl plus 1 HNO3 is called aquaresia. Forms NOCl plus 2 nascent Cl plus 2 H2O. NOCl again decomposed to form NO plus Cl. Total Cls are 3 Cls. Now gold plus 3 nascent Cl combined to form AuCl3. AuCl3 next dissolve in the HCl to form HAuCl4 complex called soluble complex. There is mechanism of solubility of gold and platinum, same type complex formation. So what is first compound means NOCl along with 2 nascent chlorines. NOCl also decomposed from NO plus Cl. That is nascent chlorines are called responsible. The compound is formed intermediate is NOCl is intermediate compound, but chlorines are nothing but nascent chlorines. So compound is NOCl is correct one. Tri-basic, that depends upon the number of OH groups. H3PO2 structure is POH H double bond O. This is only monobasic, n factor equal to 1. These hydrogens are called reducing nature. Direct hydrogen is called reducing nature. H3PO4 contains three OH, n factor equal to 3. H4P2O7 contains 1, 2, 3, 4. H4P2O7. Tetrabasic, n factor equal to 4. This is dibasic. One direct hydrogen, n factor equal to 2. One direct hydrogen. Here 4 OH groups, 4 basic, 3 OH tribasic. So phosphoric acid is called tribasic. This compound is nothing but hot and concentrate NaOH. A is equal to NaClO3. Sodium chlorate. Sodium chlorate. Oxidation number is equal to +1, X minus 6, 0, X equal to +5. Okay, thank you.